Welcome, namaste, and aloha. Some scientists solve a puzzle and stop. A rare few solve the puzzle and then keep walking straight into the questions that physics itself cannot answer. Cambridge, 1962. A 22-year-old doctoral student at Trinity College is working under Brian Pippard at the Royal Society Mond Laboratory. His name is Brian David Josephson. He is studying something that should not be possible. Two superconductors, metals cooled so cold that electricity flows without resistance, separated by a thin insulating barrier. Classical physics says the current should stop at the wall. Josephson's calculations say otherwise. He predicts that pairs of electrons, Cooper pairs, can tunnel straight through the insulator, and more, with no voltage applied, a supercurrent still flows. Apply a voltage, and the current oscillates at a frequency locked to that voltage, a rhythm precise enough to redefine the volt itself. He publishes the paper on the 1st of July, 1962. It is titled simply Possible New Effects in Superconductive Tunneling. 6 months later, at Bell Labs in Princeton, Philip Anderson and John Rowell confirm it experimentally. The impossible current is real. 11 years later, in 1973, the Royal Swedish Academy awards him the Nobel Prize in Physics. He is 33 years old, one of the youngest physicists ever to receive it. The effect he predicted becomes the foundation for SQUIDs, superconducting quantum interference devices, capable of measuring magnetic fields 100 billion times weaker than the Earth's. They map the human brain, detect submarines, and today they anchor the qubits inside every leading quantum computer on Earth. The Josephson junction is not a curiosity, it is a doorway, but something is shifting in him. In 1971, on a visiting fellowship at Cornell University, Josephson tunes his radio and hears an announcement, a lecture on transcendental meditation. He attends. Something in the speaker's account of reality matches, uncannily, what his own equations have been whispering. He reads Fritjof Capra's The Tao of Physics. The parallels between quantum mechanics and Eastern mysticism strike him with force. The youngest Nobel laureate in physics begins to meditate. Now the discovery first physicist meets the discovery first sage. Roll the clock back 5,000 years by tradition. In the 13th chapter of the Bhagavad Gita, Lord Krishna teaches Arjuna a distinction that will echo for millennia. Kshetra, the field. Kshetri, the knower of the field. The body is the field. The consciousness within is the knower. And Krishna gives the analogy, as the one sun illumines the whole world, so does the knower of the field illumine the entire body with consciousness. Two things, one reality, matter and mind, field and knower. Neither can be reduced to the other, yet neither exists without the other. Now listen to what Josephson himself would come to say, decades after the Nobel Prize. He speaks of a universal intelligence, a field of awareness that our thought processes are, in his words, not entirely localized in our brains. He describes consciousness as fundamental to nature, not a byproduct of it. The Gita called this kshetri, the illuminator. The physicist calls it universal intelligence. The word changes, the vision does not. Josephson never abandoned physics. He founded the Mind-Matter Unification Project at Cambridge's Cavendish Laboratory, the same laboratory that had unveiled his supercurrent decades earlier. His new question was ancient. Is consciousness fundamental? He wrote, I read a book called The Tao of Physics by Fritjof Capra that pointed out the parallels between quantum physics and Eastern mysticism. I started to feel there was more to reality than conventional science allowed for, and later, more directly, our thought processes are oddly dependent on universal intelligence and not entirely localized in our brains. Modern research colleagues called this heresy, but Josephson, a fellow of the Royal Society, held his ground because his ground had always been the equations. The equations, he said, were pointing outward toward something the rishis had already named. The Josephson effect showed that a barrier is not always a barrier. That which seems separate can, at the quantum level, be one. Chapter 13 of the Bhagavad Gita said it first in a different language. There is a field, and there is a knower of the field. Recognize the knower, and the barrier dissolves. So the question the Gita asks us, and the question a Nobel laureate spent his life asking, if consciousness is not confined to the brain, where does it end? Sit with that. Thanks, namaste, and mahalo.